The marketing team needs a reliable hub. Without structure, their voices remain isolated.
Welcome. Today we're learning how to build a star network topology, using our marketing floor as a real-world example. Let's start by looking at the marketing floor and identifying the problem we need to solve. The marketing team needs a reliable hub. Without structure, their voices remain isolated, leading to chaos from unmanaged peer-to-peer links. First, we need to gather all the end devices for our network. We are placing each workstation carefully, representing the team's digital desks on our canvas. This organized placement forms the foundation of our star topology, reinforcing the best practice of clear, organized device placement. Next, we introduce the central node of our network, the switch. Here we drop the MKTG_switch onto the canvas, right at the center. The switch is the heartbeat of the star network. Every connection flows through it, ensuring smooth traffic management and preventing collisions. Now it's time to connect the workstations to the switch. We are stretching the Ethernet cables from each computer to the central switch, one by one. Each link ties a marketer's voice to the hub, weaving a star of collaboration. This design reinforces the principle that one device failure won't collapse the whole system. Our star topology is now complete and ready for action. Here is the completed star topology, glowing with activity as data pulses efficiently through the switch. The marketing team is now united. Their network is stable, efficient, and ready for action, giving you the satisfaction of building a functional topology. In conclusion, the star topology offers significant advantages. The star topology design highlights resilience, stable design, easy fault isolation, and minimal network failure risk for the entire team. Now, let's hear out Nicoya Tech on a hands-on lab simulation on creating a star topology sourced from CompTIA Networking Plus.
Here we create network topology.
Each workstation is placed carefully, representing the team's digital desks.
Number one, move the marketing 5 computers and the switch to canvas. Then secondly, you're going to connect the devices to create a star topology. These are end devices. So we are going to move the marketing 5 computers and switches to canvas. So what you're going to do, you're going to drag the 5 computers to the modular canvas. So let's drag this here, then drag this here, then drag this here, then drag this here, then drag this here. Okay, so what we have created now, from there, we're going to select the switches icon. So we have here we have the end devices, here we have the switches, here we have the routers, here we have the create link, then here we have the nodes, the hide nodes, and the network map. So we're going to select the switches. So once we select the switches, we're going to drag the switch to the canvas. Then the second instruction is to connect the devices to create a star topology. So in the tools tray, let's select the create link icon. So you have the create link icon, and you're going to select market G1, then select Ethernet. Then we're going to drag the switch and select an open port. Okay, sorry. So we're going to select Ethernet and drag the switch. Then we're going to select an open port. So port 0 selected. Then we're going to do the same for this. I think it's better when we go with the number. Then you're going to select this. Sorry. So once we select that, we drag it. We are creating a star topology, so I want it to look like a star. Select an open page. Then we're going to select this, connect it there, select an open port, then connect, select an open port. So once you have done that, we repeat the process as we have done, then we are done. And then we score our lab. So I'm going to share the score on my screen, on my YouTube thumbnail, so that you see how we fared on in this exercise. Feel free to comment, to like, and share with us how was the experience as you are doing it.
Welcome to an in-depth look at network design, focusing on a critical concept, star topology. We're here to explain why this particular network architecture dominates modern local area networks. Network topologies define how devices are connected within a network. Different designs offer various trade-offs in terms of cost, reliability, and performance. The core goal of network design is simple: to create a robust, manageable, and scalable system. We need efficient data flow and minimal downtime. The star topology is defined by a central connection point, typically a hub or switch, to which all other devices connect with their own dedicated cable segment. Why is the star topology the go-to for network engineers? It comes down to key practical advantages that align with enterprise needs. Star topology dominates modern local area networks because its benefits consistently outweigh the trade-offs, making it the de facto standard in real-world enterprise environments. Its architecture is designed for ease of management and fault isolation. If one cable or device fails, the rest of the network remains operational, minimizing disruption. Let's break down the 5 core benefits that solidify star topology's position as the leading network design choice. First, star topology offers centralized control. The central hub or switch governs all data flow, which simplifies traffic monitoring, security policy application, and problem solving. Reliability and fault isolation are major advantages. If a single device or cable segment goes down, the rest of the network keeps functioning, allowing quick, isolated repairs. Star topology is incredibly scalable. Expanding the network is as simple as plugging new devices into the central switch, making it perfect for growing organizations. Performance is excellent due to dedicated connections. This reduces data collisions and allows the central switch to intelligently direct traffic for smooth and efficient communication. Finally, the centralized device acts as a checkpoint, enabling administrators to enforce strict access controls and monitor the network for any suspicious activity, aligning perfectly with cybersecurity standards. While star topology is powerful, it's essential to consider its trade-offs before implementation. No network design is without its weaknesses. The most critical weakness is the single point of failure. If the central hub or switch fails, the entire network connected to it goes down, bringing operations to a halt. Star topology also requires more cabling than alternatives like bus topology, alongside the cost of the central device, making the initial investment higher. Additionally, the overall network performance is entirely dependent on the capacity and efficiency of that central hub or switch. If it bottlenecks, your performance will suffer. When designing your network, always weigh these key factors: the need for centralized control, the importance of fault isolation, and the acceptable trade-offs regarding cost and the single point of failure. To recap, star topology offers superior centralized control, reliability, scalability, and performance, which is why it's the standard for modern enterprise LANs. Consider star topology for your next network design to benefit from a secure, manageable, and highly reliable architecture.